Hello, ladies and gentlemen, and thank you for watching the Innovator Showcase about SynSysCo's OMNI Helium Compressor. We appreciate you attending. Before we get started, though, we'd like to give some thanks to the SVC committees, the board, the executive committee, and subcommittees that worked so hard to pull together the virtual SVC show. And specifically, we'd like to thank Mary Ellen, Jackie, Chris, and Frank for all of the phone calls and emails associated with keeping us on the right track while we developed all of this. Thank you very much. Our showcase today starts out with who is SynSysCo and what are we? We're actually Synergy Systems Corporation out of Montrose, Colorado, and we like to think of ourselves as an innovative engineering and distribution company. We're also the inventor of the OMNI Helium Compressor. We are the distributor for Marathon cryogenic equipment from Sumitomo, Kashiyama dry roughing pumps, and Anesta Wada dry roughing pumps. And with these, we create vacuum systems to support coating and semiconductor and a variety of high technology applications. Lastly, we also repair a variety of cryogenic equipment, pumps and compressors from a variety of different manufacturers. Now we want to figure out who is Sumitomo. Well, Sumitomo is actually SCAI, which is Sumitomo Corporation of America Incorporated in Allentown, Pennsylvania, which means all the cryopumps and compressors that we provide are made in the United States. They're a quiet giant in the industry. They have over 20,000 installations globally, and they're well known for their 4K technology, which is used on MRI helium reliquefaction globally. Also, they are about $100 million in sales each year, and they're a subsidiary of Sumitomo Heavy Industries out of Japan, which is about $10 billion in annual sales. Well, where are we going with this presentation? It's about cryogenic system technology silos, really, and that the OEM products are not interchangeable within most system installs. Cryogenic equipment manufacturers typically use two features that keep them independent from other manufacturers. One is a power supply and phasing that is specific to the equipment used to power their cryopump. The second is a proprietary communications protocol to enable the cryopumps to communicate directly or via a network back to the tool. The manufacturers of this equipment do not use the same voltage and phasing outputs from their compressors to their cryopumps, and often the I/O is non-existent to network them, or if it is, they speak different languages. That's a hidden problem for the end users because a common platform does not exist which enables the upgrade of the systems you may have in an incremental manner. So cross-platform integrations of cryopumps is not capable due to the phasing and voltages differences between the pumps that are being used. And second, that I/O we talked about earlier does not enable them to talk to each other or to a network controller or to the tool host because everyone's speaking a different language and the I/O just locks up and these systems are blind to each other. So it also limits your ability to improve your capabilities on your systems. For instance, if there's a higher performing cryopump that would enable your process to run faster or run longer or cool down more quickly, you can't buy it from supplier A and put it on supplier B's tool or vice versa because the compressors of one manufacturer will not necessarily, and in most cases, not drive the other manufacturer's cryopump. So if you have an alternative cryopump with higher pumping speeds, you can't put it on and you can't benefit from the higher throughputs that may be available. If you have an alternative cryopump that has flatter pumping curves, which gives you better process stability, you can't put it on because it can't be driven by the compressor of the other manufacturer and most likely can't talk to any network controllers. Also, many alternative cryopumps may have a higher carrying capacity for various gases that are critical to your process. So in this case, you cannot put it on because it can't talk to the other pumps or to the tool, and it can't be driven by the other compressor, and consequently the longer times between regen that you may be desiring cannot be achieved because you can't put that pump on the system. Also, the silo technology limits the process capabilities for the end user. Even the next gen equipment coming out from many manufacturers is not backward compatible. Even with one manufacturer, staying with that one manufacturer, you may find that their latest and greatest innovations cannot be backward installed on their legacy equipment. And you're driven then to replace all the equipment at one time in order to gain the process improvement you may be able to get by using someone else's cryopump that performs better than their old legacy equipment. The incremental single cryopump or compressor upgrades are just not available, often when staying with the same manufacturer. So, how do we limit the integration for the end users by this silo? Well, they use different communication protocols. Even if a higher performance cryopump could be put on the system, if you have a network system, it cannot talk to the other pumps, the controller, or the compressor. So the equipment replacement is also limited. You're often capped to the performance and service of one manufacturer. That means a legacy cryopump parts may be hard to find or slow to be sourced. The legacy compressor parts may also be limited. There's lead times may be long because the parts aren't being manufactured as frequently, because new generation parts are being manufactured and legacy equipment's being faded out. Equipment may often be sent out of the country it's domiciled in because they're not maintaining them there anymore. Cryopump replacement in kind is limited because you cannot swap out even with the new manufacturer's product. And compressor replacement in kind is also limited. Many of the legacy compressors are being phased out and no longer available to support your systems. And global support is often limited. Technical requirements. If you're going to escape the technology silo, what's needed to do that? Well, first of all, you have to develop a compressor that will drive multiple cryogenic pumps made by different manufacturers with different IOs and drive them all at the same time on the same tool. That compressor has not existed prior to the Omni. The next thing, it has to drive standard pumps and auto regen pumps at the same time on the same tool. And you may have 2-phase motors on your cryopumps and 3-phase motors on your cryopumps. And so this compressor also has to give you the opportunity to change that phasing output to accommodate 2-phase pumps on one tool and perhaps 3-phase pumps on another tool. Lastly, you need all the electrical communications and helium supply components to operate all these pumps at the same time on the same tool, whether it's networked or not, on the same application. The technical requirements also require the development of a network interface, and that will have to cross-translate the I/O languages of different manufacturers so that the inquiries and commands back and forth between the pumps, a network controller, and a tool host can all be deciphered in a manner that each tool, each controller, and each pump is satisfied with the commands it's seeing. Because if this is interrupted, the system goes blind to the status of the pump, and often the tool will shut down and stop operating. Commercial requirements. Well, if someone's going to integrate alternative equipment, there's now the need to support the legacy equipment you're already using, plus the new equipment that's coming in. So this cross-platform has to be able to enable that incremental upgrade one chamber at a time. The market has to be there for sale or trade-in of the equipment as you move off legacy equipment, bring in alternative equipment, and then the legacy equipment should be traded in or sold to minimize the economic cost. And lastly, rebuild services have to be available if you're going to be moving from one manufacturer's pump to another. The rebuild services have to be maintained for both the legacy equipment and the new equipment until that change-out is completed. So the solution is the OMNI Helium Compressor. And what is it? Well, we developed the OMNI module, which you see here, and we integrated onto a Sumitomo compressor, which is that highly proven compressor in those 20,000 installations globally. So the next thing that happens is this compressor in the back has a switch that will give you 2-phase or 3-phase outputs to the ports on the front. And in the ports on the front, you can install a standard pump, a smart pump, which has auto regen, up to 3 each, and both of them at any given time. You can mix them, one here, one there. And also, the Sumitomo pumps can connect here, and of course, their signals can be split for multiple pumps there. So in this case, you can have the Sumitomo pumps and a variety of other pumps connected, whether they're auto regen or not, and have this compressor driving all of them at the same time. That is one of the unique items of the Omni compressor. When we integrate the Sumitomo pumps, one at a time is needed. The tools are also running the other manufacturer's pumps. Both the Marathon and the other pumps are running at the same time on the same tool. How does this work on a process tool without a network controller? Well, here's a typical outline of how this might work. You have a tool, 2 legacy pumps, and a compressor from another manufacturer. And there's no network controller. The Omni 900 compressor, as an example, can run 1 to 3 typical sized manufacturer A pumps. So you can throw in the Omni compressor if the old legacy compressor is in need of repair, and it will drive the existing pumps. Same hookups, same cables, same helium, same fittings, everything. Now, this is good because if you have an aging compressor, you have an alternative now to change it out. And 2, it could be the first step towards also changing out the pumps on the system, because one of these pumps may be satisfactory to you, perhaps on a load lock or an accelerator, and the other pump may not be acceptable because you need higher performance on an end station or a process chamber. So what this can do is you can bring in a CP pump, which is the cryopump designator for marathons, and you can run like this. Now you've mixed the platforms, solving perhaps an operational or process problem on one aspect of that tool. Or later, you could go and change the second pump. And now you've completely changed out the equipment that's driving your tool process and probably have upgraded its performance. So the Omni enables you to go one step at a time, compressor, pump by pump, to upgrade on a current process. Now, how do you do this if you have a network controller on a tool, a little more sophisticated? Well, here we have an example again of an Omni driving the legacy pumps on a tool that has a tool host CPU. The tool host CPU often comes with a network controller by the legacy manufacturer and is connected to their pumps and feeds the I/O from the pumps through the controller back to the tool. The tool sends inquiries to the controller gets the data from the pump, sends it back to the tool so it's happy with what's going on. If it's not happy, the process shuts down. So in the midst of all of that, the Omni compressor is just driving the cryopumps while they are interfacing with the controller. So the next step is, well, how do we upgrade the pumps on this system? Well, normally we would put a pump in, and we have what's called an MCC, the Marathon Cryopump Controller. And it is taking its own language and speaking to the pumps, and then would normally be sending it to a tool host compressor, the tool host CPU. But in this case, there's a problem with the languages because the MCC doesn't speak the same language as the network controller does. So the tool host now goes blind to the pumps because the languages cannot be interpreted. So what SynSysCo did is we created something called a protocol translator element. And this element will now take the language spoken by the CP Marathon pumps and convert it into the language spoken by the network controller. And then the controller will then communicate to the tool host CPU, exchange the information, send it back to the pumps through the PTE, which then translates it again to a language that's understood by the Marathon pump. So in this case, we have the whole system running. So here's an example now of the possible types of incremental upgrades. In this case here, we see a marathon pump. We just chose one, the CP8LP, and compared it to manufacturer A. And you can see here that in almost every case, this particular pump is outperforming the legacy pump. There's superior processing performance. There's in situ replacement of the helium displacer, which is unique to the marathon. And that in situ prevents you from prevents the needed dropping of the pump for most rebuilds, where in this case, on this design, you can extract the displacer and set it aside for refurbishment and install a new displacer and get your pump back to operational status in about 60 minutes. Then you go to cool down. You have spares and refurbished displacers on hand for on-demand need when you have a helium side exchange needed, and you're back to temp in about 110 minutes, and the whole process takes about 2 hours. So in this case, if someone wanted to upgrade, they would have superior processing performance of the pump itself, reduced downtime, faster helium side rebuilds, and no need to drop the pump, ship it in and out of the facility, and get it done all in about 2 hours. So this was a specific example of how an Omni compressor facilitates the ability to grab a very specific pump and put it into a process where that process can be benefited incrementally, one pump at a time, as capital and budgets provide. The release of the Omni compressors is as follows. We have several models. In the green, they are all released, and in the yellow, they're going to be released this year. And you'll see that we can drive everything from one 8-inch pump and have air-cooled and water-cooled versions, all the way up to our premier Omni 1000, which can drive multiple pumps, multiple 16-inch pumps, and everything in between. So the family of Omnis is actually quite extensive. If you want more information, this presentation has a code you can scan, which will give you other video presentations of specific models. So thank you for being with us. Thank you for attending. It's greatly appreciated.